Hi guys, you need to watch this video before you do the Zearn lessons for this week. This week you are doing Zearn lessons number 20 through number 23. I'm going to have a secret word somewhere in this video and I want you to include it with your submission. So when you turn in your copy of these notes, I want you to say the secret word was, and you can type it or you can write it on the last page. Maybe you're going to type it into the comment box in your portfolio, but I want you to tell me what the secret word was so I know that you watched this entire video. Here we go. In order to add fractions, you need common denominators. Remember, the denominator is the bottom part of the fraction. You need to make sure that that number in the bottom of your fraction is the same. When both fractions have the same denominator, when they have common denominators, your life is easy peasy lemon squeezy. For example, let's do 1/8 plus 4/8. Easy peasy lemon squeezy because my denominators are the same. So my answer is going to just simply be 1/8 plus 4/8. 1 plus 4 is 5/8. We don't need to change anything because both of our denominators were eighths. Now I'm going to do 2/3 plus 1/3 equals something. Again, I have common denominators. Those bottom numbers are the same, so I can just add my numerators. 2 plus 1 is 3. 3/3. You could simplify your fraction because you know that 3/3 is the same as 1 whole. Last, we're going to solve 4/10 plus 5/10. I know that I have common denominators because the numbers in the bottom are the same. So easy peasy lemon squeezy, I add my numerators. 4/10 plus 5/10 is 9/10. All right, so I know that in order to add fractions, I need common denominators. I realized that I have 1/3 and plus 1/6. Unfortunately, I don't have common denominators, but I can make common denominators. And I'm going to do that by modeling on my tape model, and I'm going to show you the equation I use. The first thing I need to do is represent my 1/3. So I'm going to break my tape into thirds. I actually want to use red for that, so I'm going to do that again. Okay, and I'm going to represent that I have 1/3. I'm going to shade it in. I have 1/3, but I don't have any sixths on my model. So now I need to find a way that I can make 1/3 look like sixths. And that means I'm going to use equivalent fractions. So I'm going to take 1/3 times 2 halves. I know that 2 halves is the same as 1 whole, and I also know that any number times 1, remember 2 halves is the same as 1, any number times 1 is that number. So I'm going to say 1/3 times 2 halves. To multiply fractions, and we'll talk more about this later in our lesson, to multiply fractions, you just multiply across the numerator and then you multiply across the denominator. So in my numerator, 1 times 2 is 2. And in my denominator, 3 times 2 is 6. Now I know that 1/3 is the same as 2/6. So I'm really saying that 1/3 is the same as 1/3 times 2 halves is the same as 2/6. So really, I could show sixths on my tape model. Look at this. I had 1/3 shaded, I multiplied, and now I have 2. So I have sixths. And I'm going to continue showing this on my model. Now, I started with 1/3, and now I'm going to add 1/6. I'm going to add 1/6, and I can actually see that 1/3 plus 1/6 is the same as 1/6, 2/6, 3/6. There we go. Just like on the previous page, I'm going to use a model. Instead of using a tape model, I'm going to use a number line this time. You need to make sure that you are showing your work. When you submit your notes to me, I'm going to be making sure that you have everything that I showed on my model before, and I'm going to make sure that you have everything that I show on this number line and all the other work that I show throughout this video. So please make sure you're following along, make sure that you are paying attention, and hey, the secret word is alligators. Let's keep going. Okay, so now I'm going to add these fractions. I see that I have 1/8 plus 3/4. I don't have common denominators yet because my numbers in the bottom of my fractions are different, but I know that I can make common denominators. So let's just see. The first thing I need to represent is that I'm starting with 1/8. So let's break this number line into eighths. So I'm breaking my number line into eighths. Now I'm going to just double check. I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. And I'm going to label it 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. And we know that 8/8 is the same as 1 whole, and I could show over here that 0/8 is the same as 0. So I'm starting with 1/8, and I'm going to show that on my number line. This is where I'm starting, 1/8, and I need to add 3/4 to that. But 3/4 and 1/8 don't have common denominators, so I need to say, hey, I know that 3/4 is the same as 3/4 times, I'm getting ahead of myself, 3/4 times something to get a fraction that has eighths as the denominator. So I need to think to myself first. I'm going to think, 4 times what would get me 8? 4 times 2. So I can say, whatever I'm doing to the bottom when I'm trying to find an equivalent fraction, I must do to the top. And so I'm going to say 3 times 2 is 6, and 4 times 2 is 8. I am literally showing that 3/4 is the same as 6/8 because any number, any fraction times 1, 2 out of 2 is the same as 1. 2 halves is the same as 1. So I'm literally saying that 3/4 times 2 halves, or 1, is the same as 3/4, but I get 6/8. So now I need to add 3/4. I'm going to actually change 3/4. I'm going to represent it as 6/8. I'm going to use that fraction that has a common denominator. And I need to add on 6/8. So here we go. 1, 2, 3, 4, 5, 6. Hey, that makes sense that 1/8 plus 3/4, or 1/8 plus 6/8 is 7/8. We know that if we have common denominators, it's easy peasy lemon squeezy. 8 and eighths. Eighths and eighths. So I have 1/8 plus 6/8 is 7/8. Okay, so we're going to add these fractions, but what if my sum is greater than 1 whole? 2/5 plus 4/5 equals 6/5. When my numerator is greater than my denominator, that means that it's more than 1. It's more than a whole. So let's check that out. I have, it's going to move on us. Let's try 6/5. Now, I know that 1 whole would be 5/5. And if I have a total of 6/5, and I've used part of it, which is 5/5, I have how many fifths left? I've got 1/5. So I'm really saying that 6/5 is the same as 1 whole, and let's go back to that. I'm really saying that 6/5 has 5/5 plus 1/5 in it, which is the same as saying I have 1 whole and 1/5. So as an improper fraction, that means my numerator is greater than my denominator, I would write 6/5. But for a mixed number, that means I have a whole number and a fraction to represent an amount. I have 1 and 1/5. And it's really important to recognize that 6/5 and 1/5, it's really important to realize that 6/5 and 1/5 are the same. They're equal. We know that addition and subtraction are inverse operations. So it makes sense that if I need common denominators to add, I also need common denominators to subtract. So when my denominators are the same, when I have common denominators, life is easy peasy lemon squeezy. 4/6 minus 1/6. I know 4 minus 1 is 3. I have 3/6. Again, 3/4 minus 2/4. Life is easy. The denominators are the same. Fourths and fourths. 3/4 minus 2/4 equals 1/4. But things can get tricky because look at this last example. I have fifths as my denominator, and I have tenths. 5, 10, not the same. So I need to do some multiplication. And so I have to tell myself that I am trying to find something that is the same as 4/5. So 4/5 times something is going to give me a fraction that has 10 in the denominator. I'm going to ask myself, 5 times what is equal to 10? 5 times 2 is equal to 10. When I'm multiplying to find an equivalent fraction, whatever I do on the bottom, I need to do on the top. So I'm going to say, 4 times 2 is 8. That means that 4/5 is the same as 8/10. And now I can subtract because I have common denominators. So let's say 8/10 minus 3/10 equals something. 8/10 minus 3/10 equals 5/10. And you can simplify your answer and say that 5/10 is really the same as 1/2. But I would accept the answer 5/10. All right, we are now going to subtract a fraction from a whole number. So I'm going to subtract 1/3 from 4. Now, let's pretend I'm making a recipe and I need 4 cups of flour and I want to get rid of 1/3 of a cup of flour. So I'm going to say, I know that this is 1 whole, 2 wholes, 3 wholes, 4 wholes. So I have 4, that's messy, I have 4 cups of flour, and I need to get rid of just 1/3 of a cup. So that means I'm going to have to find a way that I can break those cups apart to represent fractions. I'm going to show you that I have 4 as my whole. Now, I can say that part of 4 is 3. And then to make up my other whole, I can say my fraction unit is thirds. So I'm going to say 3/3. This is being represented in this model. So I have 1 cup, 2 cups, 3 cups, and 3 out of 3/3, which is another cup. I'm going to break the last part into thirds though. So here I am. Those are my thirds. That's 3/3. And I know that I have to subtract a third. So I'm going to subtract. That means I'm getting rid of that third. It's no longer there. I am left with 1, 2, 3 whole cups and 1/3, 2/3. Remember, we need to use our model so we can represent our work and show how we are finding our answers. All right, so we've been adding, we've been subtracting fractions. Now we're going to multiply fractions. And when we multiply fractions, you multiply across the numerators and then you multiply across the denominators. Now, I have the multiplication equation 6 times 1/3. And I can rewrite that where 6 is a fraction. I put 6 over 1 and it's just 6. So 6 over 1 times 1/3 equals something. When I multiply fractions, I just multiply across. So 6 times 1 is 6. And 1 times 3 equals 3. So now I need to find out how I can represent this on a number line. This equation can be represented in another way. So I could actually say that I'm going to use a different color just so that you can tell which part of each equation I'm representing. That 6 times 1/3 is the same as 1/3 plus 1/3 plus 1/3. That's a whole because I have 3/3 plus 1/3 plus 1/3 plus 1/3. That's another whole because I have 3/3, and I'm going to represent that on my number line. I'm going to represent that I'm breaking my units into thirds. There we go. So this is 1/3, 2/3, 3/3, just like I have 1, 2, 3/3. And I'm going to show that I have 3/3 is the same as 1 whole. And then I'm going to add 3 more thirds. So 1/3, 2/3, 3/3. I added 3 more thirds. And now we know from our addition information that 3/3 plus 3/3 equals 6/3. Just like our multiplication. This number line just gives us another way to represent our work. So if I had 6 1/3, I would literally have 6/3. Ta-da! You did it. Don't forget our secret word.